Hello, today I'm going to demonstrate how a catalyst can affect the rate of reaction. So as you probably know, catalysts speed up chemical reactions without being used themselves. So let's see that in action. So what I've got here is some zinc metal. I'm just going to take a piece of that zinc metal and I'm going to put a piece into each of the test tubes that I've got here. There's one piece. You can see it's zinc, shiny grey metal. It's not focusing very well, but it is zinc. And then what I'm going to do is I'm going to add sulfuric acid, H2SO4, to that zinc. You will know that zinc, or any metal, any reactive metal, reacts with sulfuric acid to produce hydrogen gas. So what we should see here is bubbling. So that bubbling that we can see there, if I can get the camera to focus, there we go, the bubbles you can see there are hydrogen gas being produced. Not the fastest reaction in the world, it will speed up soon, but that is hydrogen gas being produced from the zinc. So if we take a look at the bubbles being produced, see how fast they're being produced, see how many of them are being produced. So that is zinc and sulfuric acid producing hydrogen. Into the other tube, I'm going to place another piece of zinc metal from the same container. So again, piece of shiny grey zinc. This time though, I'm going to add a piece of another metal in there as well. I'm going to add some copper. Copper is actually a catalyst for this reaction. It speeds up the reaction of zinc with sulfuric acid. If I put it in, I have to make sure that it touches the zinc, which we can see there. If I get it to focus, it is touching the zinc. There we go. So we've got copper and zinc. One thing to remember about catalysts is that they don't take part in the chemical reaction. They speed it up. And I'm going to add sulfuric acid again to that zinc with the copper in it this time. And we should again see bubbles produced. But, again, if I can get it to focus, we should see the bubbles are being produced much more quickly. Now, copper is very unreactive. It doesn't actually react with acids. So that hydrogen is not coming from the copper, it's coming from the zinc. We should be able to see there is a clear difference in the amount of hydrogen that is being produced there. The one with the copper in it, the copper is acting as a catalyst and it is making it react much more quickly. The amount of hydrogen bubbles being produced is much higher when a catalyst is present. Just a reminder, the copper is not taking part in the reaction. Just wanted to prove to you that the copper is not taking part of the reaction. So I have a separate test tube set up here, this was filmed later, with copper in it, and I'm going to add the sulfuric acid, and just to prove that the copper does not react with the acid, we should see no reaction happening here. So as we can see, no bubbles. The copper does not react with the sulfuric acid, showing us that it was the zinc reacting at two different speeds. The faster reaction occurred when copper was present. Copper is a catalyst for this reaction. And here we've got a photo that I took later after the reaction had completely finished. You can see that in both tubes the zinc has completely disappeared. It's reacted with the acid, whereas in the one with the copper is still there to show it is unchanged at the end of a reaction. Thanks for watching.